And next up is Jekaterina Služenikina from the Forecast Model Department in Estonian Environmental Agency. So Jekaterina, the floor is yours.
Thank you. Can you see my screen?
Your slides are not in the presentation mode.
Now it's okay?
Now it's okay. The floor is yours.
Okay, thank you. My name is Jekaterina Služenikina. I'm a satellite specialist from Estonian Environment Agency. And today I would like to speak about the use case of the remote sensing data and the usage of ESTHub platform for Estonian Ice service. I would like to begin with the introduction and say that Estonian Ice service belongs to the Baltic Sea Ice Services Consortium, and the ice reports prepared by Estonian Ice service are distributed to the Baltic Sea Ice Services network. The main aim of this service is to provide users with precise and efficient sea ice information over marine and internal waters of Estonia. And here at this slide, you can see the example of the ice report that is shared to the Baltic Sea Ice Services webpage. Now let's look the user groups of the ice information in Estonia. Of course, the biggest group is marine traffic, different vessels and the harbors. The ice information is used in winter time for safe winter navigation, for effective planning of the ships and icebreakers routes. The Police and Border Guard Board, as well as Estonian Rescue Board, use ice information for life safety and rescue operations, to make some restrictions to go on ice and for preparing effective and quick rescue operations on ice. And finally, for the ice information is used for preventing the shipping accidents and oil pollution during winter time. As you can see on the slide, also another user group is local people, the fishermen and winter sports lovers. The ice information is issued by forecasters of the Estonian Weather Service, and the ice charts, as here you can see the example of that, can be seen on the webpage of Estonian Weather Service. When the winter conditions allow and the first ice starts to form in our region, the forecasters have to prepare the ice charts and the ice reports. The ice reports are represented in the text mode and just describe in the text form the ice conditions over the Baltic Sea in the Estonia. But the ice charts should be drawn by forecaster, and the forecaster usually have to define the different types of the ice, as well mark the places of different ice features, such as cracks or leads or ridged ice location. Also, the forecaster mark the place of the icebreakers and show the averaged ice thickness values on the ice chart. And both outputs should be prepared operationally and by 11 UTC and then distributed to the international network. Additionally to this information, the forecasters prepare sometimes the ice forecasts, but this information is delivered according to the orders. And the ice statistics are usually prepared by the end of the ice season, just to evaluate the ice conditions of the year. For preparing the ice information and in high detail, the forecaster have to analyze different sources of ice information. The first one is real measurements and regular ice observations. As you can see on the slide, the number of places where we can get the regular ice observations is quite few. But we are waiting now for the mobile application developments, and we hope to get more ice observations from volunteers and cooperational partners. Also, the forecasters look the webcams, which allow some kind of information about the ice existence near the shoreline. The forecasters also look some ice products which are available on the Copernicus Marine Environment Monitoring Service, and also analyze some ice forecasts which are available by the numerical models. And the most important and nowadays helpful source of ice information is the satellite data. Now I would like to introduce you the Sea Ice project, which is aimed to upgrade the Estonian ice charting service. This project has started more than a year ago. The project is led by IT Center of the Ministry of Environment. The end users of this project is Estonian Environment Agency. We have here several partners: Tallinn Technical University, Marine Systems Institute, the CGI Estonia, and the Rhein-Elcan. The main aim of this project is to create new solutions for collection, processing, and distribution of the various ice information, but especially based on the remote sensing data. And this system has to reduce the country's costs for ice breaking and ensure the ice safety for the public. And now I would like to focus on the different sources of ice information from remote sensing data. So the first one is radar-based measurements from SAR instrument on board of Sentinel-1. This data is quite valuable and very important for ice charting and ice reports composing, because it provides very detailed ice information and in spite of the cloudiness or illumination by the sun. So the Sentinel-1 data in both sensing modes is operationally processed now since 2019 on the ESTHub platform, and thanks to our partners from Tallinn Technical University, who provided the code for operational processing of this data. On ESTHub, the data is available quite quickly, within 5 hours after sensing time, and the data processing performs also quickly. But I have to admit that running the scripts is a quite challenge. And as I know, we are the first operational users of the ESTHub processing facilities. Complementary to the radar-based measurements, we also use a wide variety of the optical, the satellite data from optical instruments. Here you can see examples of the MODIS data on the left-hand side and the OLCI instrument. The MODIS data we don't process by ourselves. We just receive this data once per day from the NASA web map service. But the OLCI data we process operationally on the ESTHub and get processed images several times per day. And this data covers quite nicely the area of interest. Now I would like to show you the VIRS instrument, which has a bit lower horizontal resolution, but this data is also helpful for ice charting purposes. When we don't have sufficient Sentinel-1 data in some areas of interest. And what is also nice that the VIRS instrument also possible to use at night time with the night overview RGBs. This data we get from EMETSAT and process at Estonian Environment Agency. And finally, we also use the very high resolution satellite data from MSI instrument on Sentinel-2. This specific RGB we process on ESTHub, which helps to distinguish the clouds from ice and snow. Additionally to that, recently has been available the public service of Estonian Land Board, mentioned by Martin. There, through the Satiladu, we can also choose specific day when with the clear sky conditions and analyze the ice conditions with a high detail. Now I would like to speak about another developments in the frame of this ice project. We also develop a QGIS-based ice chart drawing tool. Actually, it was developed already. We started the developments from 2018 at Estonian Environment Agency, thanks to the Ryan Elken, and now it's successfully integrated into the operational process of the ice charting. This new tool enables to upload all available satellite products and images from the last 3 days. They are sorted by the date, and forecaster can choose the best possible possibly available products for ice charting and drawing ice polygons. And when the ice chart is finally prepared, it can be sent directly to the GeoServer and then shown to the public. As this development is based on the freely available platform, it raises also the high interest towards high interest to the other ice services. Another part of the developments of the ice project is development of the ice products based on the satellite data, and these developments are performed by the Tallinn Technical University Marine Systems Institute. Here we are waiting for development of several ice products, such as the ice type detection, the ice thickness detection, the lake ice, ice features, etc. The algorithms are mainly based on Sentinel-1 data, but also the Sentinel-2 and 3 data is as a complementary source of information. These products are mainly based, the development is based on the machine learning methods. And the products have to simplify the ice charting process in the semi-automatic way and improve the accuracy of the ice charts. I have to say that the product's development is quite challenging, and the reliability of the products depends on the availability of the observational data. That's why we are waiting the mobile application and to get the more and more observations for the product's development. And our final development is also regarding to the public web application. It's at the moment in prelive version, but everyone can go through this link and to get familiar with this kind of development for ice information. On the top panel, you can choose a specific time frame and scroll on the right hand side, and the layers will be changing according to the date and time. And you can here see the Sentinel-1 data as the layers, Sentinel-3, and the ice charts prepared on that specific dates. And this new web application shows as an interactive way. In interactive way, you can zoom in and zoom out, and also see the geographical position of the area of interest. So by the end, I can say that the ICE project gives more opportunities for the collecting, analyzing, and sharing more detailed ICE information. And the ESTHub gives an excellent opportunity for processing large data sets operationally. So that's all from my side, and I would like to thank you for your attention.
Thank you, Jekaterina, and thank you for being ready to start a bit earlier. So as we have some minutes, are you ready to answer a few questions, Jekaterina? I will read them. They are in the chat. There are many partners you mentioned. Do you collaborate also with Finland and Sweden?
We collaborate. Yes, we have some meetings. We had some meetings with Sweden and Finland. We share the experience, and I know that the Finnish Institute is interested in QGIS application, what we developed, and Finland also is looking for that in the future. So yes, we collaborate.
And the second one, what about the sea ice analysis and the wind energy production on sea area, the wind energy production areas, how they relate to the ice analysis?
I think that it's related to the ice drift product development, but I'm not familiar with this specific wind product.
No, it's wind parks, I think, energy wind parks.
Wind parks.
There are going to be in Estonian Sea wind parks, large wind parks with this.
Wind farms, you mean?
Yeah, yes.
Okay.
Is it gonna?
Quite interesting question, but I cannot answer on that.
So we will see in the future. Okay, so thank you, Jekaterina.